Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is lesson 1-9 for course 2, period 4, order of operations and the distributive property. So our objective for this lesson is to simplify numerical expressions involving order of operations. Okay, so remember we have order of operations because we have an agreed upon way how to work problems that have a whole bunch of different operation signs in them. We all want to be sure that we can get the same answer and that we all agree that that is how it's supposed to be. All right. So first off, let's review what order of operations tells us. Work inside grouping symbols. Remember, grouping symbols are most commonly thought of as parentheses. They can also be brackets, or they could be the division bar where you have something divided by something else. So those would be our major grouping symbols. Our next step would then be multiply and divide in order from left to right. After you've done that, you go back and add and subtract in order from left to right again. Many of you may recall that you learned the acronym PMDAS to help you remember the order of operations. P standing for parentheses. And again, we often use the P because parentheses are our most common grouping symbol. Then multiply and divide from left to right. Then add and subtract from left to right in order in both cases. Okay. The distributive property is another property that we use for simplifying expressions. Okay, basically what that tells us, and I'm going to have to talk about this a little bit because I think it makes sense, but it's a little wordy here. Basically, this is saying 9 times the quantity 4 plus 5. Now, most of us know that we could add 4 plus 5, and that's 9, and do 9 times 9 is 81, and we would be absolutely correct. However, the distributive property tells me I can also break this down into little pieces. For little numbers, we might not want to do that, but if we have larger numbers or expressions with variables in them, that might come in handy. Okay, so what the distributive property tells me is that the factor that I have outside the parentheses gets distributed to each and every term within the parentheses. When I was younger, we were taught to make the little rainbows so we know what got connected to what. So basically, instead of doing it this way, I could say 9 times the first number, 9 times 4, plus, since this is addition, 9 times 5. Okay, a while ago, we just said that 9 times 4 plus 5, 4 plus 5 is 9. 9 times 9 is 81. If you break this apart, 9 times 4 is 36, and I'm just going to pencil it in there very small, and 9 times 5 is 45. If I add 36 and 45, guess what? I get 81. So this is two different ways to get the same problem, or the same answer, excuse me. So two different outlooks on the same problem. This is an application of the distributive property of multiplication and addition, over addition, or using addition. We can also apply the same property when we are subtracting two numbers. So 5 times the quantity, 8 minus 2. We all know that 8 minus 2 is 6, and 6 times 5 is 30. Again, the numbers here aren't so difficult, but let's walk through the steps anyway. The 5 gets distributed to the 8 and also to the 2, and I'll use subtraction in between because this has subtraction in it. So 5 times 8 is 40, minus 5 times 2, and 5 times 2 is 10. That gives me 30. Here, 8 minus 2 is 6, 6 times 5 is 30. Again, this would be from this to this, would be, or even backwards from this to this, would be an application of the distributive property. We will practice with that a little bit more as well. Remember, this is introductory, so you have an idea of what's going to be going on in class. Now, here is algebra. Algebra, remember, is math, but we use more variables in it. So if I say A times the quantity B plus C, I can take A and multiply it by each term here. So A times B, when I distribute, plus A times C. Okay, I can't simplify any further and double check because I have no numbers to help me double check this time. Similarly, A times the quantity B minus C results in A times B minus A times C. So the A gets distributed both to the B and the C that are in the original parentheses. All right, so that was a quick go through of our concepts for this section. Let's look at some examples using the order of operations. We want to find the value of each expression. A is 9 plus 3 times 5 minus 1. Okay, so I see that I have addition, multiplication, and subtraction. Order of operations say I must multiply first. So once I multiply, then I have 9 plus 3 times 5, which is 15, minus 1. Once I do that, that's all of the multiplication. I go and add. So 9 plus 15 is 24, minus 1 is 23. So when I simplify this expression or find its value, I get 23. If you'll look over at the B part of this example, we see that we actually have the same numbers, but we also have a set of parentheses inserted into this expression. Therefore, it is going to change the value of this expression. Instead of multiplying first, I need to work inside the grouping symbols. So I have 9 plus 3 times the quantity 5 minus 1. 5 minus 1 is 4. Okay? Then after I've done that, I have 9 plus 3 times 4. There's multiplication. I do not add the 9 and the 3 at this point. I multiply. 3 times 4 is 12. And finally, now I'm ready to add. So when I add, I get 9 plus 12, which is 21. So again, two expressions that start out looking very much the same, but they are slightly different when we work them out, or we see that they are different. Just a couple of reminders. When you see this negative 40 over 4, remember that means negative 40 divided by 4, okay? Also, this up here where you have 8 plus 4 on top of division bar, you have to add the 8 and the 4 plus, so it's sort of like an understood set of parentheses, and then divide by 6. So that's just a couple of hints when you go through those two quick checks. Again, you may choose to do the quick check now. You can pause the video, or you can come back to it later, whichever you prefer. I am going on to example number 2, and we have an application for shopping here. You want to buy 4 CDs at a price of $11.95 each, and 2 DVDs at a price of $18.75 each. What is the total cost of items? Okay, so if we look at the words, just kind of rewording it, we have 4 CDs plus the cost of 2 DVDs. That's what I'm trying to find out, because that would be the total cost. Translating that into expressions would be 4 times the cost of 1 CD plus 2 times the cost of one of the DVDs, which is $18.75. Okay. Now, 4 times $11.95 gives us the $47.80. Whoops, I almost wrote 37. $47.80 that we see over here. And 2 times $18.95 gives us the $37.50 that we see over here. So we multiply first according to order of operations and then add. That gives us a total of 85.30. And this is money. So either put your money here, or if you're going to write it in a little a short sentence, the total cost is $85.30. Remember that the dollar sign is in front of the money amount and does not follow it. Generally, we do not label money with the word dollars. We're going to label it with the dollar sign. Okay. All right. Now, you might be wondering, when on earth might I ever use mental math? Okay, here is an example of how you might want to use it. And actually, it's even showing us how we can use it with decimal numbers. Okay, so use the distributive property to find 4 times 4.8. Okay, so here's where you have to think a little bit. If I think of 4.8 as 5 0.0 minus 0.2, and 5.0 minus 0.2 is, in fact, 4.8. Then I could say that 4 times 4.8 is the same as 4 times 5 minus 4 times 2/10. So what I'm doing here, I am breaking apart the 4.8 into 5 and subtracting 2/10. Okay? So I know that 4 times 5 is 20, and 4 times 2/10 is 8/10. Okay? That's pretty easy to do. At this point, you might be able to do that in your head. Oops. If you can't, then guess what? You come off to the side and write it down. Okay? So I am going to have to borrow. I get 19.2 or 19.20. If you think of this as money, this is like $20 minus 80 cents. So if you take 80 cents away from $20, you have $19.20. Even though this isn't a money question per se, remember sometimes thinking in terms of money helps us to understand decimals just a little bit better. Okay, I'm going to walk back through the problem one more time because it's explaining why it works. Okay, so first of all, 4 times 4.8 is equal to 4 times the quantity 5 minus 2/10. And then I'm going to use the distributive property, which means I'm going to take 4 and multiply by each of the numbers that are now inside the parentheses. So 4 times 5 is 20. 4 times 2/10 is 8/10. And I get 19.2 or 19.20 when I subtract. Okay. All right. And again, we will be going over more of these in class. I would like you to do all the quick check questions here. Please let your examples give you an idea of what I'm wanting you to do on each of them. Just a quick note over here. This one is 9 times 14. I do not want you to just work 9 times 14. Think of a way, either through a simple addition problem or a simple subtraction problem, that you could name 14 and follow the idea from example number 3. I look forward to seeing you in class, so see you then. Thank you.